Hello, this is Questionable Coding with Vladimir, and we're discussing most essential problems or algorithms that will be extremely useful in almost all of your interviews. So today we're going to talk about the problem of adding two numbers. And you might wonder, like, what's the problem in adding two numbers? You just have one number and you have a plus sign and you add it to another one. But yeah, of course, not everything as easy as it sounds, because usually the number is represented in some weird way. For example, every digit is a node in a linked list, or every digit is an element in an array, or it can be a string instead of a number. So we need to add them digit by digit or element by element, and it requires some rules that we need to enforce for this algorithm to work. There is a benefit because if you have an algorithm that can do it digit by digit, you can be given any number, like a very huge one, represented as a string, as plain text. So it can be like 1,000 symbols, and you still can add them. And in normal situation, you won't be able to add such big numbers. So let's see how it's done. So let's start with adding two numbers. It's the smallest example we can have, and two numbers are 123 and another one is 111. So we are starting to sum them up from the right, since we have a positional system and position notation, and we sum 3 plus 1, it's 4, 2 plus 1 is 3, 1 plus 1 is 2. Pretty clear. But that's not it. We also can have a different size. Let's say we have one number that has 3 digits and another one that has 1. So once again, we start from the right and we sum 4 and 1. It will be 5, 3. There is no digit in the second number, so we assume it's 0. So it's like 3 plus 0 and it will equal 3. Same with 2, 2 plus 0, 2. Another case is having a carry. So carry is something that when we have a sum of digits, we can run out of our digit, let's say not scope, but maybe base. Yeah, the base is the right word. So 6 plus 4 is 0. In a decimal system, we have digits from 0 to 9. So 10 doesn't fit in. There is no such digit as 10. That's why we just leave a remainder, and it's 0, and we carry 1 to the next column. So we have 1 here, and 1 in memory as a carry. Altogether it will be 3. And there's a special case where we have a leading carry. Once again, 1 plus 4 is just 5, but 2 plus 8 is 10. And we leave 0 here as a remainder, and we carry 1 to the third position. So what variations do we have for the task? First of all, we can have a number represented as an array. Let's assume that everything we saw before was an array. So 1, 2, 3, just array elements. And another option is having a linked list. Usually it represents a reverse number. So let's say we have number 1, 2, 3, then our linked list will start from the end. It will be 3, 2, 1, null. It makes it easier to sum two linked lists that are represented like that, because we start from the first element, then if we want to carry something, we carry it to the next one and to the next one. It can be in a normal order, but that will be a harder task for us. And the string, which is very similar to an array. In this case it's binary, but binary numbers can be in any representation. It can be an array, it can be in linked list. It changes our checks a little bit. So instead of checking if our number is more than 9, we check if it's more than 1, and we do a carry there. So it's not that hard to move from a decimal system to a binary one. Okay, so array and string representation are very similar. Linked list is a bit harder, it's a bit different, but we'll cover all cases. So let's see how our algorithm works with two arrays or strings. It doesn't matter much. First of all, you need to remember that we need to align them like to the right. It means that we are starting from the last symbol and going to the first one or digit. And that's because how our positional system works. So we start with the smallest position, and it's number 8 or digit 8 and 5 for the second number. Here I'm using the word num and num2 just to have this value, this current value. So think of it as a pointer. So it starts from the right, and another one also starts with the right. So for number 1 it's 8, and for number 2 it's 5. And we have a carry which is 0. We'll return to that. So now we need to sum up this entire part, and it will be 13. So we have the sum, and now we need to understand if we need to carry anything further, and what should we place here as the first digit. So here it's just if we think that it's over 9, if we check it, then we need to place the remainder of dividing it by 10. So it will be basically 3. It will be the first digit that we have. So we place 3 here. But we know that it's over 9, which means we need a carry. So I'm placing a carry here. Let's see, maybe it will be more clear on the second step. So after that, we need to move the pointers and start over. So what we're going to do next, we move the pointers. We basically forget about our current numbers. I'll remove them for now. We don't forget about the carry, because that's what we decided to keep for the second column. And we can also erase the sum. So the new digit is 2 for the first number and 9 for the second one. And we also have a carry. So let's sum them up. It will be 2 plus 9 plus 1, and it will be how much? 12. The situation is similar. The one thing that we should do right away after summing this up is to set the carry to 0. So right now we don't know if we'll have another carry. So let's check it. 12, is it more than 9? Yes, then it doesn't fit into one digit. In this case, we keep the first part, 2, and we should also increase the carry to have it for the next iteration. That's it. Let's move the pointers. As you might see, the first pointer is pointing to a number, to a digit, but the second one, it's out of bounds. So basically, if we would talk about indexes, it will be -1 index for this array or a string. What does it mean for us? So let's first erase everything for the final step, except the carry, because we need it, we keep it from step to step. First of all, the number will be 9, and the second one will be 0. As we agreed, if we are out of bounds, then we think it's just 0. And let's sum this up. So it will be 9 plus 0 plus 1, and it will be 10. Then we set the carry to 0. And now we need to think what to place here. So basically, we are placing a new number. I will just copy that, which is 0. And we know that it's over 9, so we set the carry to 1. The thing is that we continued all the operations till we have digits in one of the numbers. So now we don't have it. We already moved all pointers. Let's move them again just to show it. So it's somewhere completely out of bounds for both numbers. We don't want to make any additional operations that we already did, but we still have a carry. So the carry check will be like the last check before we finish. After all operations, we still need to check that, okay, carry is 1. Then we need a leading 1 for the number. So we are adding it again. So that will be our result, 1023. Let's see how we deal with a linked list. With the linked list, the situation is quite similar. So we have a linked list. Usually it's reversed, and we'll discuss this variation. So we have 3, 2, 1. We have another linked list is 1, 1, 1, 1, and we expect a number. If we will reverse it once again, it will be 1, 2, 3, 4. So that's the sum of two linked lists. The approach is similar. So we also have a pointer for both linked lists. It's basically, at first it's ahead of linked list, and then we just move it. And yeah, we move it to the next element and to the next every time. If we face null or even further, then we treat this element as 0. The same as we did for array and the string. And one more thing here, it's this sentinel. So basically we still, after all operations, we need to return a linked list, and it will be a new linked list. So we could reuse the existing linked list, but usually we just create a new one here. And we create a sentinel which will just point to the head. At first it will be empty, and we'll add element by element. So summing this up, we'll add element by element to this sentinel. So at first we'll add 4, to the 4 we'll add 3, to the 3 we'll add 2, and so on and so on. These two pointers are always in line, so there can't be a situation when one pointer is somewhere else and another one is very in front of it. Okay, so just a small note. We'll tackle this case, we'll tackle the linked list addition. It's not a sum, it's like, usually it's adding to linked list, it's called. But yeah, in the end, it's a sum of two numbers represented by a linked list. And we'll tackle this task because I think that's the hardest one from the list that we just saw. Okay, let's finally code it. So we'll start with two pointers. Do we need two pointers here? What do we have? We have two list nodes, and the first one is L1. It's a list. It's not only a node, it's an entire list. So, and L2 is a second list that we need to sum with the first one, node by node. So in general, we don't need a pointer here because we already have a list node and it's sort of a pointer. So we'll update L1 and L2 as we go. So what do we really need here is, first of all, let's start with a carry. We need a carry. It will equal 0, and let's leave everything else for now. We will continue while L1 or L2 are there. If they will be null, then we'll see if the second one is null. If both are null, then we won't continue. Okay, that's clear, I think. And what do we need? First, we need to get the value of the first number and the second one. So I would call them num1, and num2. So num1 will be L1 value, and num2 will be L2 value. But that's a problem because in some cases, if we have different lengths of our linked list or our numbers, then it can be a situation when it's already null. So we need to check it. If L1 is there, then we use the value. If not, then we use 0. It's very important step. All steps are quite important, but this one it's easy to forget. Okay, so we have two numbers, we have a carry, and now we need to find the sum. So let's find the sum. It will be sum of num1 plus num2 and plus the carry that we have. Right now it's not obvious, it's 0, but we'll set it for the next iteration. Okay, we have sum, and we need to check if it's more than 9. If sum is more than 9, then our remainder will be this one, which basically means sum equals sum divided by remainder divided by 10. Okay, and in this case we need to set the carry to 1. What else should we do? The next thing that we should do, we need to understand how to add our number to our result. So where will we keep the result? Let's create a sentinel. Sentinel is a term that we use for a node that is not real. It just keeps the next value. So the sentinel will be, you'll see what does it mean. So it will be a list node with any value and with null as next. So we already have the description of the list node up here. Otherwise we should have created the list node as a data structure. Okay, we have a sentinel, but still the sentinel shouldn't be changed, and when we worked with a linked list we need to keep the current state. So I'll call it current node. And at first it will be equal to sentinel. You'll see how it will go. So when we have the sum, when we have this proper number without, so it's just a digit from 0 to 9, what we're going to do, we're going to add it to our result. So first of all, we'll have our current node next equals to new list node, and the value will be sum, and the next will be null. Or we can just leave it because it will be null by default according to their description, and here we can also leave the null. Okay, so current node equals next, and it's new list node. What else? Now we need to prepare for the next iteration. And for that, what we need to do is we need to move the current node pointer to the element we just added. But that's not it. We also need to move L1 and L2 to the next element, as we discussed. So L1, it will be L1 next, and L2 will be L2 next. But here we have the same problem. If L1 is already null, then we need to check it and leave it as null. So if L1 is there, we'll pick next. If not, then we'll pick null. Same here for L2. Cool. But some things are missing, and it's mostly related to the carry. So first of all, when we sum this up, then we checked if sum is more than 9, and we set the carry to 1 to transfer it to the next column or next node. But there is a place for a bug. Basically, there is a pretty hard to find bug here. So after we use the carry, we need to set the carry to 0, because if our number won't be more than 9, then we want the carry to be 0, because we're not moving anything. And if it was 1 before, without this, it will remain to be 1, which is not good. And I think the last part that we need to figure out is what to do if we passed everything here. So while worked till we have L1 or L2, but what happens then? How do we deal with the leading carry? And for the leading carry, we are going to do the following. We're gonna check if the carry is there, and we're gonna execute the same thing we did before. But instead of the sum, we can place 1 here, we can place carry here, but let's place 1. So we know that it's our leading digit. If the carry is not there, then we shouldn't add it. So what's next? We just need to return our sentinel next. Let's try to run it to find some bugs. We won't debug it to save some time. It's working fine. I will submit just to understand if other cases are fine. Yeah, they are fine. And I guess everything is accepted. So that's how it goes. That's how we add 2 linked lists. We can get rid of the carry. We can use sum for that. It will require some modification, but carry looks pretty obvious here comparing to some extended operations with the sum, but you can try it on your own. And other implementations with a string or with an array, they will require to iterate an array from right to left, or a string from right to left, rather than having next here as we had. But basically it will be the same. So I highly recommend to understand how it's implemented, to implement it yourself, to be completely sure about the solution. That's it. Thank you for watching. See you next time.